Welcome to Jackal DIY and Tech. In this video, we'll take a look how to use this ultrasonic sensor, which sends a signal and receives it, and how you simply use it to display the distance, and then also how to turn on different LEDs based on the distance. So it is green between 1 meter and 60 centimeters, then it goes to yellow, which is not that visible, and then when I'm close it goes to red. So you can use something like this if you have a garage. This will tell you the distance so you know how far you actually have to go before you make a boo-boo and crash. So in this video I'll be using this HC-SR04 ultrasonic sensor, which is used to measure distances, and based on the distance you can do, well, whatever you want. In this case I'll first show you how to just display the distance and then how to turn on different LEDs based on the distance, and we'll just do a simple modification to the code and a simple bit of wiring to the LEDs. Now, how does this sensor work? As you can see, it is quite big, and you do have smaller alternatives like maybe ultrasonic sensors that you see in a car bumper. This is something like that, but it is bigger. And how it works is one side sends a ultrasonic signal out, it then bounces, and the other side picks it up. Does it have any downside? Well, it does. It doesn't detect soft objects like humans that good. It is limited to 1, maybe 1.5 meter, but it depends on what you wear. Me just wearing normal clothes, it worked for 1 meter, 1.5 was a stretch. When it comes to detecting walls, that was okay, but it also depends what kind of walls you have. Do you have just rectangle walls? Do you have convex, concave? All that counts. Now at the back we have a bunch of chips. I have no idea what they are, what they do. I just want to do something with sensing the distances. So this is what this video is about. It's not about knowing all of the intricacies, how something works, though if you want to know, I'm sure there is stuff available online that you can search, but I will just show how to connect a sensor like this one to a small board, which in this case is ESP32-C3 Supermini, which is basically half the size of the sensor. And this board is quite cheap. I think it's below $2 if you order it on AliExpress at least. If you order it on Amazon, I'm sure it costs a little bit more, but I will leave a link to it down below, and also this module in case you want to do something similar to this. Now when it comes to the connections, you pretty much have 4 pins. Now the wires do not come with the module, so you will need some kind of wires, but the pins, they have VCC, which is voltage, GND, which is ground, then we have trig for trigger and echo. The VCC and the ground are pins that are, well, understandable, I would imagine. So on the PCB you will usually see a VCC or a GND. In this case we have just G for the ground, which in my case is yellow. And as for the VCC, this board has 3.3 volts and 5 volts. In this case you can use both of them, so 3.3 or 5 volts, but when I'll be making the LEDs, I will connect the LEDs to the 3.3 volt and this to the 5 volts. So I'll just use 5 volt for now. And when it comes to the accuracy, I think the accuracy is a little bit better if you connect it to the 5 volts. Now I know this is very tiny and my camera is not meant for microscopic work, if you will. As you can see, The size of this is half a thumb, so it is quite a small board. Now for the other two pins, trigger and echo, you can basically connect them to any pins that you want, because we will specify those pins inside the code. And in this case, I will use pins 6 and 7. You just have to make sure that you connect the right pins when you specify them. So now the sensor works if you look at the display, but it's not really that accurate. But if you just want to save your car from accidental bumps inside the garage, I think the accuracy is good enough. So in this case, it's detecting 158 centimeters, and I have no idea what it is being detected. Maybe the ceiling, but it does a good job when I'm lowering my hand. Now the only thing that you need is some code. We'll be using the Arduino IDE, and we're not using any specific library. As you can see, I have not done anything. What I have done is define the pins, so 6 and 7 for the trigger and the echo pins. The trigger pin is output, so we send the signal, and the echo pin receives the signal, so it is an input. In the loop, we write the signal, so the trigger pin is low, then we set it to high after a small delay, and then set it to low again after a small delay. We then make some calculation, so basically how long it takes for the signal to bounce back, and the echo pin is the one that receives it, and based on the duration we measure the distance. We then print out the distance, so without print line, without the ln, it means that this will print in the same row. So we have distance, the actual distance value, and centimeters at the end, and we have a delay of 2 seconds. I could write this code, but it was a lot faster for me to just ask the ChatGPT, and you can basically get a code fairly simple if you just know what to ask. But it does help if you actually know a little bit of code, because you may need to do some adjustments. In this case, it works as intended, at least I think it does. Now I could make some changes with the divisions to get a bit more accurate distance reading. That's about it. Now what I have also read is that you can put something around the sensors so that the signals don't interrupt each other. Now if you're new to all of the Arduino stuff, as I am, what you'll want to do is when you have the board connected, well, first you'll have to install the board manager. In this case it's ESP32. So I have the ESP32 by Espressive Systems. So you will install this board, but before you can, now if you're new to Arduino like I am, I suggest you watch the previous video on how to install the boards. As for uploading the sketch to the board, you will simply click on this button, upload it. You will see it in the output, just like so, and once it's done, you can open the serial monitor so you can see what it's writing on the top right. So as you can see, when I put my hand up, over the sensor the distance changes. And no, it does not go to 1 centimeter, as you can see. It is not that accurate. But if you need that kind of precision, I suggest you get a sensor that is meant for the task. And now for the fun part, let's hook this up with a bunch of LEDs. So now that we have the basics out of the way, what else have I done besides just connecting the module to the ESP32-C3 Supermini? Well, as you can see, I have a bunch more wires that go to the LEDs and then also connect to the module. So the thing that I have disconnected is, as you can see, the ground wire. It is not connected to the ESP. It is now on the PCB. This is then connected to the ground, and this ground is shared with all of the LEDs. I have used a 330 ohm resistor and then connected this blue wire to all of the negative pins on the LEDs. And then I have used a bunch of wires, connected each leg individually, the positive ones, to 3 different pins on the ESP board. So in this case, pins 1, 2, and 3. So in this case, I believe pin 1 is this one. So when I'm at the top, between 60 and 1 meter away, the LED is green. When I'm closer, it is orange. And when I'm all the way close, it is red. And if we take a look at the code, as you can see, we still have the trigger pin and the echo pin set as they were. I have defined 3 different pins for the LEDs. In this case, I have used 3, 2, and 1. It's not 5, it is 1. Then we set the pin mode, so this has to be output for all of the pins. And we set them to low by default because we want the LEDs to be off. If at the beginning we don't use the low value and we just leave it to default, the value could be something between low and high. So it could be somewhere in between, and that could mean that the LEDs would be partially on. What changes did I make in the loop? Basically a bunch of if statements. So this is basic logic that anyone should be able to understand. It may not be the cleanest code, but it is understandable. So if the distance is equal or greater than 100, then all of the LEDs are off. Currently that is not the case because I believe the camera is being detected as it is in the range of this probe. Then we have if the distance is between 60 and 100, we have the green LED, which is not the case as the camera is being detected. Maybe if I pointed this in a different direction, so now we did get a green reading. Then we have this yellow one between 30 and 60, and lastly, if it is anything else, so no conditions are met, then we have the red LED. And at the end, I simply printed out the LED states, so I know which one should be on and which one should be off, based on the actual distance. That's it for this video. If you found it helpful and would like to see what more cool stuff you can do with Arduino, subscribe to the channel, and we'll do something else in the next one.